All right, welcome back everyone. Today we're going to be doing section 1.4, which is perimeter and area in a coordinate plane. Perimeter, of course, you guys will remember is the distance around a shape. The area is all of the stuff in between the perimeter. And today we're going to be talking about the perimeter and area in a coordinate plane, meaning on the XY axis. So obviously we're still talking about lengths if we're talking about perimeter. And then we are also going to hit polygons today. So you'll be given the definition of a polygon, but also the different names of polygons. So for example, you might have a triangle, quadrilateral, pentagon, hexagon, etc. There will be a slide later on for you to write down the different names. All right, so in order to be a polygon, first of all, we need to talk about a plane figure. So in geometry, an object that lies on a plane is called a plane figure. So remember, plane from section 1 is basically that little rectangular rhombus looking shape that is like a flat thing that goes on forever. So in class, I used like a piece of paper to describe a plane. So here is the definition of a polygon. So a polygon is a closed plane figure. So the reason we call it a closed plane figure is the word closed, meaning that it doesn't have a side on it where it's like open. So like if I filled the polygon with water, there wouldn't be a place for it to escape. So it is closed, meaning it doesn't have any gaps on the edges. It is a closed plane figure, and it has to have these two properties. So first of all, it's formed by 3 or more line segments that are called sides. So if you think on a triangle, you have 3 sides. If you think on a square, for example, you have 4 sides. So it has 3 or more segments that are called sides, and then each endpoint of the side is called a vertex. So where you have 2 of the segments coming together, or 2 of the sides coming together, it creates a point, and that point is called a vertex. So if you look over on the side here, you'll see I have a picture of a polygon. You'll see the sides right here. So this would be a side. We have another side over here. Notice that all of the sides do touch, so it is a closed figure. And notice that we do have a vertex at each one of these intersections here. Remember, when 2 segments intersect, they intersect at a point. So we do have the points here where the sides come together. In a closed plane figure or a polygon, those points where they come together is called a vertex. Okay, so has to be formed by segments. So is a circle a polygon? If it has to be formed by 3 or more segments, then a circle is not a polygon. So on the next page, I'm going to give you some examples, and you're going to tell me, are these polygons? So is the first shape here a polygon? I would say absolutely not, because it has a curve. It does not have all segments. What about the star? Okay, so does it fit the qualifications, a star? So let's go back. First of all, is it a closed plane figure? Yes, it doesn't have any gaps. Is it formed by 3 or more line segments? Yes. Do each of those line segments have endpoints that come together, creating a vertex? They do. So I'm going to say yes, the star is a polygon. I would say no for the heart and this wonky looking square curved thingy. I would say no for those 2. Of course, a triangle is a polygon. And then we have this shape here at the end, also a polygon. All right, next we're going to talk about concave versus convex. I'm sure you've heard these words before. So concave versus convex, some people say concave is the one that has a cave in it, meaning that it kind of goes into itself right there. Convex is the one that always points outwards in all directions. Another like tip, if you have trouble remembering which one is which, if you're going to trace out all the sides of the polygons with a straight line, then the line cannot go through the figure, or else it's concave. So for example, on this first one, the purple figure there, if I trace out all the sides, let me use a pen instead. If I trace out all the sides, notice that none of the sides would go inside to the purple area. However, on the concave shape over here, this arrow, if I trace out all the sides, notice that it does go through the middle of the figure when I do some of them. So if it goes inside the figure when you trace it, it's called concave. And so there's another picture, okay? Next, we're going to talk about all the names of the polygons. Now, to be clear, you do have to have these memorized. So by the time we take the chapter test, you're going to need to know all the names of the polygons. On the test, I'm going to give you a question that says name the polygon, and you'll have to say that is a decagon or something like that. Okay, so on the next page, I'm going to give you some time here. If you'll pause the video and just copy this down into your notes, unless you printed the notes ahead of time, then you can just kind of keep on going. So if you don't have these written down, go ahead and pause me for a second and copy all this down. Okay, so the first one we have here, number of sides, has 3 sides. That's called a triangle. I'm hoping you remember that one. Number of sides being 4. So yes, that could be a square, but it could be other things, right? Like it could be a rectangle, could be a rhombus, right? So we want to call that a quadrilateral because there are more than just squares that have 4 sides. So a 4-sided shape is a quadrilateral. 5-sided is pentagon, 6-sided is hexagon, 7-sided is heptagon, okay? 8, of course, you guys know is octagon, kind of like octopus, has 8 sides. Number 9 or 9 sides, kind of a weird one. It's called a nonagon. 10 is decagon. Now we don't have the name for the 11-sided shape in here because it's not one that we're requiring you to know. If you're interested, you can go look it up. How about if you look it up and it's 11 sides, tell me next time you're in class what the name is and maybe I'll give you a piece of candy. If it has 12 sides, it is called a dodecagon. So it is like a decagon with the word do in front. So it's called a dodecagon. The last one is called an n-gon when it has n number of sides. Now that is not because an n-gon exists. That's saying you could plug in any number for n and call it that with a gon at the end. For example, a 14-sided shape would be called a 14-gon. If you don't know the name, I shouldn't say if you don't know the name. If the name is not listed here, you'll call it a whatever the number is, gon. Okay, so for example, if it was 11 sides, you would call that an 11-gon, since I'm not making you memorize that. If it has, let's say, 1,300 sides, that would be called a 1,300-gon. Okay, so you get the point there. If I don't give you the name for it on this list, then you can just put the number in the front and say gon right afterward. All right, let's move into actually doing some examples. So on here, we're going to classify by the number of sides. We're also going to tell if it's convex or concave. So on the first one, let's see how many sides it has. It has 1, 2, 3, 4 sides. And so I'm going to go to my list here that I just wrote down. 4 sides is called a quadrilateral. So we're going to call this a quadrilateral. Now we need to decide, is this convex or concave? And I hope you're seeing that it does have like a segment that kind of goes into the shape. And so that is concave. All right, let's do the next one. The next shape is this blue shape here. We have 1, 2, 3, 4, 5, 6, 7 sides. So what is that polygon called? So again, check your list. That is called a heptagon. Okay. And then convex or concave. So hopefully you're noticing all of the vertices are pointing outward from the shape. So that is convex. All right, last shape over here, we have 1, 2, 3, 4, 5 sides. And so again, check your list if you don't have it memorized yet. 5 sides is called a pentagon. And of course, you're seeing again that this is going into itself. And so that would be called concave. Okay. All right, next page is going to be just a list of formulas. So again, if you will pause the video and copy all of these down, this is the formulas for perimeter and area. So perimeter is the ones that have a P, and then area is the one that has an A. So if you'll take a second, copy those down into your notebook if you haven't copied them down already. And then once you're ready, you can go ahead and hit play again. Okay, so now that you have all of these written into your notebook, we're going to do some examples. So before we move on, let's go over these real quickly. Perimeter, remember, is the area, not the area, but the length around the edge of the shape. So like if you were looking at your backyard, if you have a fence, your fence is the perimeter, right? Okay, so for a triangle, there's really not a special formula. You just simply add all three of the sides together. Whatever they are, add them up. That's your perimeter. And technically, that would work for anything. Okay, don't know what happened here. Let's try again. Okay. And then the area for a triangle is 1/2 times the base times the height. So that's what the BH stands for, is the base and the height. Okay. On a square, I don't know why it does that every time I erase now. On a square, let me see if I can erase all that. There we go. On a square, we have the perimeter is 4S. Now that's because if one side is S, so if you see this guy right here, it says S, that means that all of these are S, right? On a square, they're all the same, okay? So if you knew what S was, let's say it was 5, you could just do 4 times 5 because there's 5 sides. Or I'm sorry, because there's 4 sides. So we have the perimeter listed as 4 times whatever the side length is. Now, if you just want to add all of them together, you're going to get the same thing. For the area, you sometimes will see it written as length times width, but isn't the length and the width the same on a square, right? Like the lengths and the widths are the same number. So on a square, instead of doing length times width, sometimes you'll see it written as side squared, because you're multiplying the side times the other side. So last one we have over here is a rectangle. Again, you can simply add up all the sides on this if you want to. The short way of doing it is saying 2 times whatever the length is plus 2 times whatever the width is. And then of course the area of a rectangle is simply just length times width. So we have 3 examples and then we'll be done. So first one is to find the perimeter, okay? And so we look in the picture here, we see that it is a triangle. And so we know that the perimeter is just simply when we add up all the sides. So let's call this X, Y, and Z. So the perimeter is X plus Y plus Z. Now the reason I didn't use ABC is because you can see it already used ABC in the picture. Okay. So let's see if we can fill in some stuff here. For example, if you look at this segment right here, segment Z basically, or segment AC, we could actually count and see how long this segment is, right? So it is 1, 2, 3, 4, 5, 6 units long. So I don't have to do anything fancy. I can just count them up and I see that Z is 6 units, okay? All right, I see that on segment Y, I can also do the same thing. It's just a horizontal line here. We have 1, 2, 3, 4, 5 units. So for Y, we have 5. And then when I look at X, I'm a little disappointed, right? Because I see that this is a diagonal line. And we learned in the previous lesson that when you have a diagonal line, you cannot just simply count the units. You have to use a formula. So take a second, look back in your notes real quickly. You'll see a formula written in there. That formula is the distance formula. Okay, so let's see if I can move this stuff up a little bit. Okay, so remember the distance formula is already in your notebook, but if you want to rewrite it, that might be a good idea. The distance formula is when you take the x values and you subtract them. And remember, you take the y values and you do the same thing. So remember, we always cluster the y's together and we cluster the x's together. Okay, so our goal right now is to find the distance right here on the triangle, the hypotenuse actually. So the distance between point A and point B. So we're going to do what we did the other day where we group the x's together. So first of all, we have two x values there. We have a -2. Actually, remember last week I told you, we're going to just write all that out first and then we'll fill it in. Okay, so again, the x values in the picture are -2 and 3. And then the y values are 3 and -3. Okay, so make sure you cluster your x's together, your y's together. Remember, I'm not looking at point C at all right now because I'm only looking at the distance from A to B. So I don't really care about point C right now. All right, so then you're gonna grab your calculator and you're gonna type all of that in at once. Remember we talked about that last week, how you can simplify it yourself or you can just type it all into your calculator. So let's grab a calculator. And I'm going to type all of this into my calculator at one time. So if you'll clear your calculator, we want to use the square root button. So if you look, it is right here. See the little green square root button? In order to do anything that's green on your calculator, see how we have a whole bunch of green stuff? You have to hit the second button first. So I'm going to hit the second button, and then I'm going to come down to that little square root, and it's on the x squared. So I'm going to hit that next. Okay, and that's going to give me the beginning of my square root. Okay, so what we're going to do is we're going to type in the parentheses first. So you're going to type your parenthesis and then your -2 minus 3 and then close your parentheses. So it should look like this right now. Notice that the negative sign is a different symbol than the minus sign. So when you're saying -2, you're going to use the negative symbol, which is down at the bottom. But when you subtract, you're going to use the subtraction symbol. So just make sure you see the difference in your calculator. Next, you'll see that we need to square this set of parentheses. So the squared button is the same button that you used for the square root. So it is still going to be that little x squared button right here. So if you hit that, you'll see that it puts your squared. All right, now remember, all of this is going under the square root. See how the bar across the top just continues to get longer. So make sure that you don't arrow outside of this bar. You still want to be underneath here when we do our next set of parentheses. So in the formula, you'll see a plus sign next, and then start your next set of parentheses, and you'll do 3 minus -3, close your parentheses, and then hit squared again. So now it should look like this. Notice again, I'm pointing out the fact that this line goes all the way across the top. If you don't have that, you might need to clear it and start over, okay? Now I'm gonna hit my enter. And when I do that, it's going to give me, remember, the radical version or the square root version, which is the square root of 61. So I'm gonna go ahead and write that down. But remember, when we're talking about the length of something, or in this case, even the perimeter of something, it would be weird for me to say like, oh yeah, my fence in my backyard is the square root of 61 feet long, right? That would be like super odd to say that. So we're gonna use our little double arrow button right here, and we're gonna hit that button. And when we do that, it's going to convert from radical form to decimal form. And again, I think we'll just round to the nearest tenth. So I'm going to say 7.8. Okay, so to recap, we needed the area right here, or not the area, I'm sorry, I keep saying that. We needed the distance right here, or the length, okay, of x. And so to find that, we did the distance formula and we got 7.8. Now, the question was not to find just the length of x, right? So if we go all the way back over here to the beginning of the problem, we needed to find X, Y, and Z so we could add them together to find the perimeter. And so I'm going to now plug in X, which we now know is 7.8. And now we can add all of these together to find the perimeter. So grab your calculator, add the 5 and add the 6, and you'll see that we get the perimeter is 18.8 units. Okay, and that is our answer. All right, next we're gonna do a similar problem, but we're gonna do area this time. So you'll see this one is asking for area. So again, if you flip back over in your notebook to where we wrote those formulas down, the area of a triangle is 1/2 times the base times the height. All right, so if we look in our shape, the base is right here. And we just need to know how long that base is. And thankfully, we don't have to do the distance formula. We can just count 1, 2, 3, 4, 5, 6, 7, 8 units long. So it is 1/2 times 8. Now the height, I'm going to go back to the formula sheet. The height you'll see in the picture here is talking about this distance up and down in the triangle. So that blue, that line that I just drew. The height is the distance from the top to the bottom. It is not one of the slants, right? So like if I ask you how tall you are and you're like, well, I don't know, I need to measure. Okay, you wouldn't take a measuring tape and go from your head down like over there, right? You would go from your head straight down to your feet, and that's how tall you are. That's your height, okay? Same thing for the triangle. I'm not gonna measure from the top of the triangle out to the side. I'm gonna measure from the top of the triangle straight down to the base. So in this picture that we had, you'll see that the height is right here, straight up and down. And if we count that, it is 1, 2, 3, 4, 5, 6 units. Okay. And you've already got your calculator out, so if you'd like to use it, you can. I'm going to do this one in my head. 1/2 times 8, or half of 8, is 4. 4 times 6 is 24 units squared. So remember, area is units squared. Perimeter is just regular units. All right. We have one more problem, and then we'll be done for the day. It says, you are building a rectangular shed in your backyard, and it's going to use the blueprint that's given over here in the corner. It wants to know what is the area of the floor of your shed. So if you look at the blueprint, it's like we're looking straight down on the shed, and that's the floor that you're looking at there. They want to know what is the area. So first of all, we need the formula. The area formula for a rectangle is just simply length times width. Okay, so let's look at this picture over here. The length across the bottom. Now, they do give us a little key right there, right? It says that 1 unit is 1 foot. So that is 1, 2, 3, 4, 5, 6 feet long. So I'm going to put 6. And then the width is 1, 2, 3, 4, 5 feet wide. And so the area, of course, would then be 30 feet squared. All right. That's pretty much it for today. So you'll notice that in our standards, we talked about polygons and the lengths. We also talked about the area and the perimeter. And then today, the only thing that you have to do is watch this video. It is a long one, but your assignment is actually not going to be until tomorrow. So you're done for today. The assignment will be posted underneath this video, but if you look at the due date, it's actually not due until tomorrow night. So this is not your assignment for today. This is the assignment for tomorrow. If you'd like to work on it now, of course you can. But again, not due until September 1st. And I hope you enjoy my joke there. All right, guys, I hope you have a great rest of your day, and I'll see you soon.